Chapter 3.1 Least common multiple and greatest common factor. Okay, first of all, let's find out the definition of least common multiple. We call it LCM. Okay, a number that is a multiple of two or more numbers is called the common multiple of these two or more numbers. Okay, so LCM. Okay, LCM is the smallest common multiple of two or more numbers. Okay, common multiple, so least common multiple. So the smallest common multiple is called the least common multiple. So let's find the least common multiple of 6 and 8. Okay, 6. Okay, now what are the multiples of the number 6? Okay, multiple of 6 means 6 times 1 is 6, 6 times 2 is 12, 6 times 3, 18, 6 times 4, 24, 6 times, let's keep going, then 32, 40, 48, and 56, and so on. So these are the common multiples of 6. And the smallest is 6, right? And how about 8? What are the multiples of the number 8? So it starts from 8. 8 times 2 is 16. 8 times 3, 24. Then next one is 32. So 8 is 32. For this one, this is 30, right? Sorry. This should be 30. 24 plus 6 is 30, 36, and 42, and 48, and 56, and so on. Okay, multiple of 8 is 8, 16, 24, 32. So 32 plus 8 is 40. Keep going, 48. And then, okay, so look at this. Okay, 48 plus 6 is 54, right? And then multiple of 8. So 48 plus 8 is 56, and so on. Alright, so from this one, let's find the common multiple. Okay, so we have multiples of 6, multiples of 8. And let's find the common multiples. So isn't 24 a common multiple? So 24 is a multiple of 6 and 8 as well. There's another one, 48. So 48 is a multiple of both 6 and 8. So these are the common multiples. So there are so many common multiples of these two numbers. So from this one, we can find the smallest one, which is 24, right? 24. So we know that the common multiples are common multiples of 6 and 8 are what? 24, 48, and if you keep going this, then there will be 72. And then add 24, then 96, and so on. So these are the common multiples. So from this, the smallest common multiple is what? 24. So we call this 24 the LCM. Okay, the smallest common multiple. So we use the least common multiple. So 24 is the least common multiple. Okay, so one way of finding the LCM is this. Find the multiples of each number and then check the common multiples and then get the smallest one. Okay, so always the common multiple comes from the larger number of these two numbers. So always common multiple comes from the larger number, which is 8 is greater than 6, right? So if 8 is not a multiple of 6, then get the next multiple of 8, which is 16. And check 16 with 6. If 16 is a multiple of 6, then 16 will be the LCM. But since 16 is not a multiple of 6, find next multiple of 8, which is 24. And 24 is a multiple of 6, right? 6 times 4 is 24. So yes, 24 is a multiple of both numbers. and 24 is the least common multiple. So least common multiple comes from what? The larger number. So this is a method of finding LCM. Okay, let's try another method of finding the LCM using the factorization. Okay, prime factorization. Actually, it's a prime factorization. So let's find the LCM of 6 and 8. Okay, 6 and 8. Okay, now let's do the prime factorization of 6 and 8. So 6 is a product of 2 and 3, right? 2 and 3. So the leaves are 2 and 3. So 6 can be written as 2 times 3. Okay, how about 8? Okay, 8 is 2 times 4. And then 4 is 2 times 2. The leaves are 2 and there are 3 2's, right? So product of 2's, right? So this will be 2 cubed. 2 cubed. All right. Since after we do the prime factorization, what we do is we will select the factor that has the highest power. So we're going to circle the highest power of each prime factor. Okay, highest power of each prime factor. So here's a prime factor 2. Here's another 2. But this 2 has power 3, right? Power 3. So this one has the highest power. So select this, circle this one. And 3. Okay, 3 is the only one. So that will be the highest prime factor, right? So circle this, circle the highest power of each prime factor. Then the LCM is the product of the factors that we circled. So 3 times 2 cubed, which is 3 times 8, so 24. So 24 is the LCM of these two numbers. Okay, can you see it? There's another method. Okay, another method is this. Okay, write 6 and 8 like this. So we want to find the LCM of 6 and 8. So write 6 and 8 on one line. And I'm going to draw a little mark like this, little symbol, L symbol like this. And find the common factor of these two numbers. So in this case, 2 can divide 6 and 8. So 2 is a common factor. So we're going to divide this 6 and 8 by 2. So 6 over 2 is 3, right? 3. Or 2 times 3 is 6. Okay, 4, 8. Okay, now 2 times what is 8? 4, right? 4. 2 times 4 is 8. Or 8 divided by 2 is 4. And then we have 3 and 4. Okay, 3 and 4 does not have, there's no common factor between these 3 and 4. So we are done for this. And once there's no common factor, then what we do is we will multiply all the numbers, all the leaves. So in that case, so it will be multiply this. Okay, multiply everything on the outside numbers. So that's the LCM. So LCM is the product of all the numbers. So 2 times 3 is 6, 6 times 4 is 24. So this is the LCM. Can you see it? So LCM, L looks like this one. This is L, right? L. So multiply everything on this L shape. Everything in this L shape. Okay, so so far we learned 3 methods finding the LCM. Okay, then let's find the LCM of 12, 18, and 40. Okay, let's use the method 1. So method 1 is, let's find the multiple of each number. So multiple of 12 is 12, 24, 36, 48, 60. This is not an efficient way, but let's try. 72, and then 84, 96, 108, and so on. Okay, how about multiple of 18? That is 18, 36, 54, 72. And then that actually is not a good method because it takes a lot of time. It has to be, actually this is no good because the LCM is, if you see the LCM, then LCM is 360. So you have to go all the way up to 360. 360, all the way up to 360, even 40. 40, 80, 120, 160, all the way up to 360. So this is not an efficient. So not a good method. So why don't we use method 2? Okay, method 2 is what? Write each number in what? In prime factorization. So, okay, 12 is 2 times 6, 6 is 2 times 3. So we're gonna write these three numbers. So 2 squared times 3. Okay, how about 18? 18 is 2 times 9, 9 is 3 times 3. So 18 is the product of these three numbers, so write those in a product. These are all prime numbers, right? Okay, how about 40? 40 is 2 times 20, 20 is 2 times 10, 10 is 2 times 5. So 40 is a product of these four numbers. So 2 cubed times 5. Then from this, we're gonna circle the factor that has the highest power. So here it is factor 2, 2 squared, 2, and 2 cubed, which is 2 cubed is the largest one, right? How about 3? Okay, there are two factors, 3 and 3 squared. So 3 squared contains the highest power, and 5 is the only one, so this is the largest one. So from here, LCM is the product of all these circled numbers, right? So this is equal to 8 times 9 times 5. Then this is equal to 360. So 360 is the LCM, right? Okay, let's try method 3. Okay, method 3 is write all these numbers in one line and then divide these three numbers. Okay, find the common factor. So common factor means it's a number that divides all these numbers. So let's start from 2. So 2 can divide all these numbers. So 12 divided by 2 is 6, or 2 times 6 is 12. 2 times 9 is 18. 2 times 20 is 40. Okay, now from here, let's find the common factor. Okay, 2 is not a common factor, and 3 is not a common factor. So there's no common factor. Okay, we want to find the LCM of three numbers, right? Three numbers, but there's no common factor for all these three numbers. Then select a common factor for two numbers. Okay, so find the common factor of two numbers because we don't have a common factor that divides everything, right? Okay, so this one should be over here, right? Over here. And then this one is what? Find the common factor of all numbers, right? All numbers. So since there is no common factor for all numbers on the second stage, we will find the common factor of two numbers. So 6, let's consider 6 and 9. So 6 and 9 has common factor 3, right? 3. Then 6 is 3 times 2, 9 is 3 times 3. And 20, just bring it down. Okay, bring it down. Alright. Then let's find another one. There's no common factor for all these three numbers, 2, 3, and 20. But there is a common factor for 2 and 20, right? 2 and 20. So 2 divided by 2 is 1. 3, just bring it down. And 20 is 2 times 10. Alright, and there is no common factor for 2, right? So we stop. And then multiply. The LCM is what? Multiply all the numbers in the L shape outside, right? So that is the LCM. So you can write it. LCM is the product of 2 times 3 times 2 times 1 times 3 times 10. Okay, so this is 6, 12, 12 times 3 is 36, 36 times 10 is 360. Bingo. So this is the common factor, LCM, least common multiple. So we use 3 methods. The first method is hard because it has to go all the way down to 360. So let's give up method 1 and use method 2 or method 3. So method 2 is really powerful, this one. And method 3 is also good method. This is also a good method. But method 2 is really important. So don't forget this method. Okay. If you know method 3, then that's good. Alright, so this is how we find the LCM. And next, let's learn how to find the greatest common factor. Okay, greatest common factor, GCF. Okay, the greatest common factor, we call it GCF, is, okay, first of all, a number that divides another number evenly is called a factor of the number. So 18, here's a number 18. So let's find a number that can divide 18 evenly. So 18 can be divided by, evenly by what? 1, right? 1. So 1 times 18 is 18, right? So 18 can divide, 1 can divide 18. So 1 and 18. Okay, let me write 18 here. So 18 is also, can divide this number 18. And also 2 can divide 18, right? How about 2 times 9 is 18? Also 9 can divide 18. Okay, how about 3? Yes, 3 can divide 18, right? 3 times 6 is like 18, right? 6. And then 6 also can divide 18. How about 4, 5, and nothing. So 1, 2, 3, 4, 5, 6. So there are 6 numbers that can divide 18. So we call each number a factor. So there are 6 factors that can divide 18. Alright, so we just find factors of a number, and a number that is a factor of 2 or more numbers is a common factor of those 2 numbers. Okay, for example, okay, let's find the factor of 24 and 36. And for this 24 and 36, let's find the common factors. Okay, the factors of 24 is what? 1. So 1 times 24, right? 1 times 24. How about 2? So 2 can divide 24. And if you divide it, then it will be 12, right? 12. So 12 is also a factor. How about 3? And 8. Right? How about 4? Yes. 4 times 6. How about 5? No. How about 6? Yes, 6. So 2, 4, 6. There are 8 factors. There are 8 factors of 24. How about 36? Okay, 1 times 36. 2 times 18. Okay, 3 times 12. And then 4 times 9. Okay, what else? 5, no, 6 times 6, right? 6 times 6. All right. So these are all factors of 36. So what are the common factors of these 2 numbers? The common factors, we have to find the common factor. So 1 is a common factor, right? 2 is a common factor. 3 is a common factor. 4 is a common factor. 6, there are so many. How about 12? Yes, 12. And that's it. So the common factors of 24 and 36 are 1, 2, 3, 4, 6, and 12. All right. Then the greatest common factor. Okay, what's the greatest common factor? So we found common factors of these two numbers, 24 and 36. So the greatest common factor is 12, right? 12. So the GCF is the largest common factor. Greatest common factor. So greatest common factor, we find what? The largest common factor. So in that case, we gotta know the factors of each number. So this is the method of finding GCF. Okay, there's another method. Okay, let's check another method. So the second method is this. We will use the prime factorization, just like what we did in finding the LCM. So 24. Okay, let's write the 4 in prime factorization. So 24 is 2 times 12. 12 is 2 times 6. 6 is 12 times 3. So 24 is the product of these four numbers. So you can write it as 2 cubed times 3. How about 36? Okay, 36 is 3 times 12. 12 is 3 times 4. 4 is 2 times 2. So 36 is a product of these four numbers. So let's write 2 first. So 2 squared times 3 squared. Alright, so we just did a prime factorization. So next step is, okay, circle the lowest power of each prime factor that occurs in both factorization. We are looking for the common factor, right? This is a common factor. Common factor. Common factor means it's a factor that occurs in both numbers. So in this case, 2 and 2, they occur in both numbers. So 2 is a common factor. But in this case, we will select the lowest power. So 2 squared is 2 is lower than 3, right? 3. So we will circle 2 squared instead of 2 cubed. And how about 3? The prime number 3, prime factor 3 occurs both number. And then the power for this is 1 and the power for this is 2, right? The exponent is 2, this is exponent 1. So we will select the prime factor that contains the lowest exponent. Okay, so the GCF is the product of these two circled common factors. So this will be what? So GCF is a product of 2 squared times 3, which is 4 times 3, so 12. Okay, 12 is the GCF, just like the method 1. Okay, then there's another one, method 3. Okay, let's try method 3. So for the method 3, we will, okay, let me write method 3. Okay, we will do the same thing similarly to finding the LCM. So let me write these two numbers, 24 and 36 on one line. 26 and 36 on one line. Draw the L shape. Okay, 24, right? This is 24. And then we are looking for always find the common factor. Okay, find the common factor. Just like what we did in the LCM, finding the LCM. Always start with finding the common factor and then divide it. So the common factor is 2, right? 2. So 2 times what is 24? 12. 2 times 18 is 36. And do the same thing. 12 and 18 has common factor, so we'll do one more time. And the common factor of these two numbers is 2, so this will be 6. 2 times 9 is 18, right? Okay, is there any common factor between these two numbers? Yes, 3. So you divide these two numbers by 3, then this will be 2 and this will be 3. Okay, is there any common factor? No, right? 2 and 3 does not have a common factor, then stop. Stop. Okay, for LCM, we multiply everything on the L shape, but for the GCF, we will select, look at this, the GCF, okay, the GCF looks like this, isn't it? This is G, right? G. So we will select every number on the vertical side. The vertical side. So product of this, the numbers on this vertical side is the GCF. Okay. So you can write it. So GCF is the product of all these three numbers, which is 12, right? 12. Done. Simple, isn't it? So at least you gotta know method 2. Okay, at least. Method 3 is optional, but method 3 is also useful. Okay, let's find the GCF 14 and 27. Okay, let's use the first method. So 14. So write the prime factorization of 14. So 14 is equal to, isn't it 2 times 7, right? 2 times 7. And 27 is 2 times 9, right? 2 times 9. Okay, let me write it here. 27 is 3 times 9, and 9 is 3 times 3. So 27 is 3 cubed, right? 3 cubed. All right. And then, okay, this is the second method, is the second method. So let me write the second method first. So from here, is there any common factor? There is no common factor, right? There is no common factor. Common factor. So the only common factor is what? The only common factor is 1, right? 1. So the GCF is 1. So actually there's a common factor 1, but other than that, there's no common factor. So actually the GCF is only 1. How about using the method 1? Okay, 14. Okay, what are the factors of 14? 1 and 7 and what? 14, right? How about 27? 27 is 1 times 27 and 3 times 9, right? What else? That's it, right? That's it. So in this case, there is only one common factor, which is 1, right? 1. So that is the GCF. Okay, how about using the third method, using the L shape? So 14 and 27. Is there any common factor between these two numbers? No, 1 is the only one. 1 is the only one. Nothing, right? Nothing. So since there's nothing, 1 is the common factor. That's the only common factor. So that will be the greatest common factor. So if there's no common factors in common, then the greatest common factor is 1. Okay, this question is a little bit tricky. Okay, there are two types of classes. One is 25-minute class and the other one is 40-minute class. And for each, after end of each class, there is a 5-minute, waiting times, going to next class. So we have to add 5 minutes to each type of class. So 25-minute class, it will take 30 minutes. And for 40-minute class, it will actually take 45 minutes. So here is the 25-minute class. And so together, this will be 30 minutes, right? 30 minutes. Here's another one, which is 45 minutes, right? 45 minutes. So, these two classes starts at the same time. Then, how long will it take? How long will it take? We don't know. This will keep going, right? Keep going. So they will end at the same time. They will end at the same time. So we're gonna find how long will it take to get here. Then how many 25-minute classes were there, and then how many 45-minute classes were there. So that's what we're gonna find. All right. So we will find what? We will find the period starting from here at the end here. Start and. Alright, then actually this will be the LCM, right? LCM of 30 and 45, right? LCM. So if we find the LCM of these two numbers, then they finish at the same time. Alright, so let's find the LCM. Okay, which one do you want to use? Okay, let's use the method 2. Okay, 30. So 30 is 3 times 10, isn't it? 3 times 10. How about 45? 45 is, okay, let me write it here. 45 is, okay, 5 times 9, and 9 is 3 times 3. So this is the product of 3 squared, and then times 5. Okay, for the number 30, that is, okay, 30 is 3 times 10, and 10 is 2 times 5. So you can write it as 2 times, we have to write in prime factors. So 2 times 3 times 5. So we're going to circle a common factor only, right? Common factor only with the lowest exponent. So here it is factor 2, but factor 2 does not occur on number 45. So 2 is not a common factor, and 3 is a common factor. And then this is a power is 2, and this one is a power 1. So select this one, right? And 5, there's only 1. There are 2. 5 is a common factor, and their exponents are the same. So select any one of these two. So from here, LCM is 3 times 5, which is 15. Oh, sorry. We are looking for the common multiple, right? Common multiple. This is the greatest common factor. So this is not right. Sorry, this is not right. So what we're gonna find is, okay, let me write it again. 2 times 3 times 5. So we are looking for the LCM, right? LCM. So LCM means we will find a factor that contains the largest exponent. It doesn't matter whether it's a common factor or not. It's any factor that contains the largest exponent. So 2 is the only one, so that's the largest one. And 3 is, there are two factors of 3, so we will select the largest one. And 5, so they are same, so we select one of these two. So LCM is the product of these circled factors. So that is equal to 2 times 9. This is 2 times 9 times 5, right? Then 2 times 5 is 10. 10 times 9 is 90. So 90 minutes is the LCM. So after the class started, so 90 minutes after the class started, they will end at the same time. All right. So this will be 90 minutes. Then how many 25-minute class are there? So 25-minute class is actually 30, right? So you will divide, okay, for 25-minute class. 25-minute class, which will take 30 minutes, right? 30 minutes. So why don't we divide 90 by 30? So there will be 3 25-minute classes. How about for 40-minute class? So 40-minute class is 45 minutes, right? 45 minutes. So divide 90 by 45 minutes, then it will be 2. So there will be 2 40-minute classes and 3 25-minute classes. All right. So if we are looking for a larger number between two numbers, then what we do? We look for the LCM. Larger number, then find out LCM. If you are looking for a smaller number between two numbers, then we will find GCF, common factor, greatest common factor. Find a larger number, then what we do? Find LCM, least common multiple. Larger number is common multiple, right? Larger is common multiple. So we will select the least one. And looking for the smaller number, then smaller numbers are common factors. So among those common factors, we will get the largest one, so GCF. Okay.